Here's pre-calc. This is problem 11-67. It says a channel flows from north to south at a rate of 15 miles per hour. So I wrote a little grid here with north, south, east, and west. And I'm saying if it goes south, I just drew a vector. I just drew this for notes for myself as I read the problem. So it goes from north to south at a rate of 15 miles per hour. And then the next sentence says, a sailboat heads at an angle of 30 degrees upstream at a rate of 40 miles per hour. So this one confused me because I wasn't sure if I should have had the 30 down here or here, because it's going upstream, like north is upstream. So it turns out when it says 30 degrees upstream, they want the 30 to be here. That's 30 degrees upstream. So I drew a vector with a magnitude of 40 because it was 40 miles per hour. And then a strong wind blows directly northwest at a rate of 30 miles per hour. So this is north, this is west. If it's directly northwest, this whole quadrant here is 90 degrees, so that's going to be 45 degrees right there. So I basically drew, like, I don't know if you noticed this, but we've got triangles here. So we've got, here's how a 30, 60, 90 triangle looks. If the 30 is here, then whatever this is, the hypotenuse is twice that measure, and the adjacent is the short side times square root 3. And here's a 45, oh, there's my 30, 60, 90, and 45, 45, 90. So you can do it that way and just figure out, it asks for component form, I believe. It says write each of the vectors in component form, so we just want like the x's and the y's. So you can use your triangles, like I don't know if you can like pause the video and look right here how I did it with triangles, or you can use cosine and sine because these are right triangles here. So let's say I'm looking at the water. Well, the water is pretty easy because you can just look at it and say, well, this is 0, like if this is the y-axis and the x-axis, this is going to be 0 and then negative 15. So that's where that comes from. But like for the boat one, if I want this one, isn't this cosine? Because cosine is adjacent over hypotenuse. So I could say cosine of 30 is adjacent over hypotenuse. So if I want that adjacent side, I multiply both sides by 40, which is the hypotenuse, and I get 40 cosine 30. So that it turns out you can use that little trig trick just to go straight to that if you want to. You can just go 40 cosine 30 is going to give you this side, and 40 sine 30 is going to give you this part right here. And so, or you can use your triangles, your graph, whatever you want. So basically you're going to get some ordered pairs, which are what they're wanting when they say component form. Component form is, well, it's kind of like an ordered pair because this is an x and this is a y. So that's the answer to letter A. Then letter B wants the resultant vector in component form. So I just took the 3 vectors that I had and I added them all up component-wise. So if you add those numbers up, you'll get a decimal that's about 13.428, or however you want to round it. And then you add all these 3 up, you should get that number. And so that's the answer to letter B. And then letter C says, what will the sailboat's true course and speed be? So we've already got it in component form right here. So, but when they say the speed, that means they want like the hypotenuse. And the course, that means they want like an angle measure. So what I did is I just took, this is my x, and this is my y. I just drew them in a little triangle, and then I realized all I have to do to find the speed is use Pythagorean theorem, like a squared plus b squared equals c squared. And that gives me the speed, which is, if you can follow that, that's 29.45 miles per hour. And then the direction, I realize I can use inverse tangent, because tangent is opposite over adjacent. So tangent of theta, I can say tangent of theta equals opposite over adjacent. So I can inverse tangent both sides, which I've done here, and that turns out to be about 62.88-ish degrees upstream. So that's the answer to letter C. And then letter D says, if the channel is 20 miles wide, how long will it take to cross the channel? So that was hard for me to understand what they're asking me, so I had to actually draw a little channel that was 20 miles wide. And then I know I have the angle. So let's say they start here, and we know, because we know this, their angle measure, and how long will it take them to cross the channel. So oh, sorry. Yeah, letter D. If the channel's 20 miles wide, how long will it take them to cross the channel? So, oh, I think I just divided 29.45 miles per hour and then divided it by 20 miles, and I got 1.4725 hours. So I think that's how I did that one for letter A. I think I used this for something else. Letter D. Letter E says, how far north from its starting point will the sailboat exit the channel? Yeah, that's what this is. So how far north? So this will be the how far north part. So I said, well, I know this is 20 across here, and I know this, I got this by, it's 29.45 miles per hour times 1.4725 hours. I know that's how far the boat is going to go, so that's got to be the hypotenuse. So then I just did tangent. Is that what I did? Yeah. Oh, and I really didn't need that part for this. Tangent is opposite over adjacent. So I showed my work right here. Multiply both sides by 20, and I get 39.05 miles.